People seek to satisfy their needs and wants. We're motivated to increase our well-being through consumption of goods and services, but we are limited by our ability to pay for those goods and services. A consumer's options are constrained by their budget and the prices of the different options available to them. We call this the budget constraint. Just like utility, budget constraints are something we can represent with a mathematical function. But this function always takes on the same form. Our budget, represented here by the letter Y, is what we have available to spend on goods and services, represented by A and B. If we multiply how much of A we get by the price of A, that will tell us our total spending on A. And if we multiply the price of B by the amount of B we get, that will tell us our total spending on B. And we can do this for every good or service we buy. When we total it all up, it would need to be less than or equal to our budget. Let's go to our example from the last video where our only options are pizza and burgers. Let's say we have $20 to spend. Pizza costs $2 per slice, and burgers cost $4 per burger. Our budget constraint would be that the $20 must be greater than or equal to what we spend on pizza, 2 times the number of slices we get, plus what we spend on burgers, 4 times the number of burgers we get. To make things easier on ourselves, let's also get rid of the notion of savings and just think about consumption now. This would mean we want to spend all of our budget. So for this example, we would say that $20 is what we have to spend on pizza and burgers, and we want to spend everything we have. That would mean we want to choose quantities for pizza and burgers that totals up to exactly $20. To better understand the buyer's problem, we can graph this budget constraint. We will put the quantity of burgers on the vertical axis and the slices of pizza on the horizontal axis. Let's think about the consumption bundles available to us. With $20, we can afford as many as 5 burgers. But if we bought 5 burgers, we would have no money left for pizza. Nevertheless, we can place 0 slices of pizza and 5 burgers on our graph. That bundle is represented by this dot at coordinates 0 and 5. One alternative to that bundle is buying 2 slices of pizza for $4 total and 4 burgers for $16 total, adding up to our $20 limit. That corresponds to this new point at coordinates 2, 4 on the graph. We can also afford 4 slices of pizza and 3 burgers, or 6 slices of pizza and 2 burgers, or 8 slices of pizza and 1 burger, or even 10 slices of pizza and no burgers. All of these options cost $20. And if it is possible to buy fractions of a pizza or burger, a point on the line which connects these dots is also an option. But even if you can't, the line implied by the equation is what we label the budget constraint. One big implication of thinking about our choices this way is that the prices we put on pizza and burgers don't matter, at least not in the way you might think. What matters for our decision about what to buy is not the prices of what we want, but the opportunity cost of what we want. What the budget constraint represents is scarcity. If we look at our set of consumption bundles, we can compute the opportunity cost of choosing one thing instead of another. Here we can see that in order to get 2 slices of pizza, we have to give up 1 burger. And that is true for each step along the table. This trade-off is how we would define the opportunity cost. To get 2 slices of pizza, we have to give up 1 burger. So in order to get 1 slice of pizza, we give up 1/2 of a burger. That is the opportunity cost of pizza. We always put the opportunity cost in terms of what we give up to get 1 more of something. So the opportunity cost of 1 slice of pizza is 0.5 burgers. Let me really make that clear. If I were to give you this budget constraint or this table of values and ask you, what is the opportunity cost of pizza? You would answer 0.5 burgers. That is what you have to give up to get one more slice of pizza. Note also that the slope of our budget line is negative 0.5. Because pizza is on the horizontal axis, this line represents the opportunity cost of getting more pizza. For every slice of pizza we get, we lose 0.5 burgers. We can also look at this from the other direction. To get one burger, we have to give up 2 slices of pizza. This one is nice because we don't have to do any dividing, but the opportunity cost of one burger is 2 slices of pizza. The buyer's problem is deciding which of these bundles we really actually want to buy. And what we will see is that this depends on the opportunity cost. And the opportunity cost is determined not by the absolute price of each item, but by the relative prices of each item. If we take the price of pizza and divide it by the price of burgers, we get the opportunity cost for pizza. 2 divided by 4 is 0.5, and the opportunity cost of pizza is 0.5 burgers. Likewise, if we take the price of burgers and divide it by the price of pizza, we get 2, which is the opportunity cost of burgers. For the buyer's problem, prices don't matter. Relative prices define the true cost of consumption because they represent our opportunity cost. The only reason I don't want to buy more pizza is because my budget is limited, and buying more pizza means buying fewer burgers. If I want more pizza, I have to give up some burgers. That is the cold, hard truth of the budget constraint, and that is the fact we must consider when deciding which bundle to buy. Of course, circumstances change, and so too will our budget constraint. If our budget went up to $24, that would shift our budget line. The new budget line would be parallel to the old one because the relative prices did not change. But by shifting outwards, it shows that we can afford larger quantities of burgers and pizza than before. So when our budget rises, the budget line on the graph shifts outwards but remains parallel to the old line. Okay, let's go back to the old budget, but consider what happens when the price of pizza increases to $4 per slice. We can still afford the same amount of burgers as before, but we can afford less pizza. So our budget line rotates inward. We could still buy 5 burgers if we wanted, but if we go all in on pizza, our maximum shrunk from 10 slices down to 5. Notice that the slope of our budget line changed from negative 0.5 to negative 1, reflecting the new ratio of prices. In this scenario, our opportunity costs have been altered. The opportunity cost of pizza is now 1 burger, while the opportunity cost of burgers is now 1 pizza. Why does that matter? Pizza got relatively more expensive. If I cut my budget from $20 down to $10, then at $2 a slice, I would only be able to buy 5 slices. But in that scenario, I would expect this person to reduce both how much pizza they buy and how many burgers they buy. A budget cut would lead to reductions across the board. But when the price of pizza rises, like it has here, I would predict that this person will reduce how much pizza they buy, but they might increase how many burgers they buy. Consider this quick aside. Where would you expect the average quality of oranges purchased by consumers to be higher? New York, where they import all their oranges, or Florida, where they grow the oranges? Most people would probably think, oh, I bet the oranges in Florida are more delicious. They're so close to the source. But those of us thinking like economists know better. Let's make things simple. Let's imagine there are two kinds of oranges, good ones and mediocre ones. Obviously, more people want the good ones, and they might be more expensive to produce, and so for both reasons, they will cost more. Let's say that in Florida, the good oranges go for $1, while the mediocre ones go for 50 cents. Well, these options are also available in New York, but since New York has to import them, we need to incorporate the transportation costs. When it comes to transportation, it doesn't matter what kind of orange it is. Let's say transporting an orange adds 50 cents to the price. Then in New York, a good orange is $1.50 and a mediocre one is $1. Now think about what people are going to buy. Mediocre oranges are still pretty good, and in Florida, buying a good orange means giving up 2 mediocre oranges. But in New York, buying a good orange means you only give up 1.5 mediocre oranges. The opportunity cost of a good orange is much lower in New York. And so I expect more people to be willing to fork over the $1.50 for a good one, meaning that on average, the oranges bought in New York will be better than the ones bought in Florida. This is the power of relative prices. If you don't believe it now, I'll prove it to you soon. But first, let's think about a price decrease. Return to our example with a budget of $20. What happens when the price of burgers falls to $2 each? In this case, the budget line rotates out to reflect the fact that we can now afford more burgers, but not more pizza. And even though burgers are not less expensive than pizza, the fact that they are now relatively less expensive than before means people are likely to shift their consumption towards burgers. This is the buyer's problem. Our budget constraint limits our options and forces us to choose. So, what should we choose?